Welcome to lecture 29 of this series on Python tutorials. Today we'll be discussing another data structure which is a lot like lists and it also resembles strings in a lot of ways, tuples. Tuples are sequential data structures, meaning they can be indexed as well as sliced. We have seen similar properties for lists as well. Also, tuples are a lot like strings in the sense that tuples are immutable. Once we create a tuple, we cannot change its contents. That means once I have created a tuple, I cannot change the value of an element present at a particular index. Once I have created a tuple, I cannot append new items to a tuple, which means tuples are data structures which once created cannot be changed. So whatever values we want to store in a tuple, they'll have to be provided at the time of creation. Once the tuple is created, we cannot make any further changes. And like other sequential data structures, it is used to represent a fixed collection of items. Here, we'll try to understand tuples by answering a few questions. So, let's start by asking ourselves the first question, that how do we create an empty tuple? Now, in order to create an empty tuple, there are two options. Either we use the pair of parentheses, which is the identifier, which is the symbol for a tuple, or we could use the keyword tuple followed by the pair of parentheses. Both work. Both work, and we can try this out. But before that, remember, what did I just mention? Tuples once created cannot be changed. So if I'm creating an empty tuple, that means I'll not be able to add new values to it. So with that in mind, let's try to execute this cell. And as we can see, it has been executed successfully. Now there's nothing to show, there's nothing to display for these two tuples because they're empty. What we can do is we can verify whether two tuples have been created or not. And how do we do that? We do that using the type function. So if I pass my tuple 1 to the type function, and if I pass my tuple 2 to the type function, then what happens? Then I get back the output saying that these are tuples. Fine. The next question that we want to answer is, can we assign values to a tuple? This part I think is clear to you by now. We just now mentioned a while ago that tuples once created cannot be changed. Tuples are immutable. That means tuples cannot be assigned values at existing indexes. Also, tuples cannot be appended with new values. So here what we are trying to do is we are trying to assign the 0th index of tuple 1 with a value of 5. This will not go through. We'll get an error message. Let's execute this. And there you have it. You get this type error stating that tuples are not those data structures which support item assignment. That means tuples are immutable. Let's try to answer the third question, which will help us understand tuples better. Can we create, or how can we create a tuple of integers? So far we have been dealing with empty tuples, which to be honest is not of much use. You would want to create a tuple containing values. So here we want to create a tuple of integers. How do we do that? Very simple. We can enclose the values within the pair of parentheses. And if we do that, if I execute this, I see that the execution is successful. And now if I print it out, yes, there you have it. You see that we have been able to successfully create another tuple containing three values, 2, 3 and 5. So that is how we create a tuple of integers. Next, next let's try to create a tuple of strings. How can we create a tuple of strings? Now in order to create a tuple of strings, you might be tempted to think that just like we created a tuple of integers, all we have to do is pass the string values within the pair of parentheses. That is what we did in case of integers. You saw in this particular cell, the one that I've just highlighted, tuple 3 is assigned a sequence of values 2, 3, and 5, and these values are enclosed within a pair of parentheses. So tuples, remember, are sequential data structures. That means the order in which they are created matters, which is why we are able to index tuples. And this order is preserved, mind you. This order is preserved as well. And if we try to create a tuple of strings in a similar way, you might, like I said, you might wonder that, okay, this will work, but it will not. And as you can see, this does not go through and we get an error. Because if you are looking to create a tuple of strings, you cannot pass the individual strings like the way we have done. Because remember, string itself is a data structure. And if you're looking to do something like this, the Python engine will think that you're trying to create multiple strings. You're trying to create multiple strings using a tuple. Now that does not happen. As you can see, it says, the error message says that the tuple expects just one argument. That means you can pass a series of strings, that's fine, but these strings have to be passed in another data structure. Most suitably, you enclose your strings that you want to pass, that you want to create a tuple with, you pass them in a list. So if we do that, if we print it out, we see that we have a tuple of strings now. I hope this is clear to all of you. You could probably go back a minute or two in the video and have a look at what I just spoke about, and I think it will be clear. Anyway, I'll just repeat it still for the sake of completeness and to not make any assumptions. Here we are trying to create a tuple of strings. That is the objective. Now, can we just pass the strings within the pair of parentheses? The answer appears to be no. The reason for that is this string is a data structure, it's a sequence. So what the tuple is expecting is, it is expecting one sequence. A tuple at a time expects one sequence. Of course, we can have a sequence of sequences. That means we can nest sequences in a tuple. We'll see that in a later example. But here, if you're trying to nest a sequence, then there is a separate way of doing it. Here, a tuple, this tuple function, if I can call this a tuple function, this tuple function will be expecting just one argument. It will be expecting one argument. Now, this one argument can be a single value or it could be a sequence. Here, if you are looking to create a tuple of strings, what you have to do is you have to pass the set of strings as a sequence. So if we pass the set of strings as a list, then it works fine. As you can see, if I scroll down, if I scroll down, there you have it, right? So the tuple of strings is created. Now, the question is, can tuples contain mixed types? Just like lists, tuples are also heterogeneous in nature, and we can have a tuple containing integers, strings, and fractions. So here you see tuple 5 has been successfully created. The next question that we are looking to answer is, does tuple support indexing? If you have a data structure which is sequential in nature, it will support indexing, it will support slicing. Tuple is a sequential data structure, so it supports indexing. It supports both positive as well as negative indexing. So if I'm looking to print out the element at index 4 of tuple 5, so I'll just show you what is tuple 5, then it will be easier for you to follow. So if I print out tuple 5, this is what it is. And if I try to print out the element at index 4, I'll get back good, which is this particular element. So indexing starts from 0. At index 0 you have 1. At index 1 you have hello, and so on. So good appears in index 4. So when we try to get this value at index 4, we get back good. Tuples also support negative indexing. If indexing is supported, if positive indexing is supported by data structure, by sequential data structure, mind you, negative indexing will also be supported. So if we pass -2, we get 13. Negative indexing, how does it work? If you remember from our discussion on lists, good is assigned an index of -1, 13 is assigned an index of -2, 3.14159 is assigned an index of 3, and so on. Here we are looking to extract the element at index minus 2. Which is that element? That element is 13. So we get back 13 as the output. Now, unlike lists, tuples do not have a huge repertoire of functions. There are only two functions available with a tuple. One is the count function and the other is the index function. So we'll try to answer this question and see a demonstration of the count function. We are looking to find the frequency of an element of a tuple. We are creating a tuple called tuple 6, and now when we are trying to count how many times this element 1 has appeared, what are we doing? We are calling the count function on tuple 6 and we are passing 1 to it, and here you go, we get 3. That means this element 1 has occurred 3 times in a tuple. As you can see, it has occurred once, twice and thrice in a tuple. If you change this, so if you pass 3 here, you get back 2 because 3 occurs once, twice. I hope that makes sense. Next, can we find the index of an item in a tuple? The answer once again is a yes. And how do you do that? You do that using the second function, which is applicable for tuples, which is the index function. So if we pass a value to a tuple, again, what exactly was tuple 6? I'll give you a quick recap. So if I print out tuple 6, this is what I get. And if I pass 1 to the index function, what does it mean? It means that I want the index, the first index of this value 1. So which is the first index of 1? This one, right? So that comes out to be 0. If I print this, I get 0. I don't need this particular cell. Similarly, if I want to find the first index of 3, of the value 3, so is 3 present in my tuple 6? Yes, it is present at index 3 and it is present at index 5. What will I get back? I'll get back index 3 because I'll always get back the first index of an item, right? So if I get back the first index, I get back 3. So that was about the index function. Now can we find the length of a tuple? The answer again is a yes. If we use the len function, like we have seen with strings and lists, we can get the length of a tuple. So the length of tuple 6 comes out to be 8. Concatenation, is it possible with tuples? Once again, the answer is a yes. If I print out tuple 5, this is what it looks like. It is a heterogeneous tuple. And if you remember tuple 6, again, let me print it out for you. So if I print out tuple 6, what do I get? This is what I get. Now I want to concat tuple 5 and tuple 6. So what will happen? All elements in tuple 6 will be appended at the end of tuple 5. And the resultant tuple will be assigned to tuple concat. Let's execute this and let's print it out. There you have it. So you had your elements of tuple 5, 1, hello, 3.14159. So you have all those elements at the beginning. And then you have the elements of tuple 6 concatenated at the end. So these are the elements of tuple 6 and they have been concatenated at the end of the elements of tuple 5. And this resultant tuple has been assigned to the variable called tuple concat. So that is how we concatenate tuples. A very interesting question is, can we create a one item tuple? So far, all the tuples that we have created consisted of more than one item. Can we create an exactly one element tuple is the question. So you might be again tempted to think that if I pass 1 within a pair of parentheses, it works. But if you print out the type of tuple 7, you will find that it is of type int. So what's the workaround? If you're looking to create, for some reason, if you're looking to create a single element tuple, you would have to end the element with a comma. You would have to end the element creation with a comma. So here I want to create a tuple having exactly one element, and that element is, let's say, 100. So what I have to do is I have to type 100 and then give a comma. If I do that, then, and if I check the type of tuple 8, I get back tuple. So that is how we create a one item tuple. Next question, a very important question is, can we slice tuples? If you can recollect what tuple 6 and tuple 4 are, this is what you get. Let's try to slice tuple 6. this is my tuple 6, the one that I've highlighted, and I want to slice from. So if you have a slicing notation like this, where to the left of the colon you have nothing, it simply implies that there is 0. So having 0 colon 4 and having colon 4 means the same thing. That means I'll be extracting elements starting from index 0, so starting from 1, and I'll be going up to but not including index 4. So 0, 1, 2, 3. So I'll go up to 3. These are the 4 elements that I'll get. As it happens in slicing, whether we are slicing a list or a string or a tuple, it remains the same. The idea remains the same because these are all sequential data structures. All sequential data structures have these common properties. They can be indexed in both positive and negative fashion. They can be sliced, so they can be concatenated. Their length can be found. All these properties are applicable for all sequential data structures. And also, what we can do is, if it's a sequential data structure, we could also index an item of the data structure. So if it's a sequential data structure, we can index an item. I think I already mentioned this. So you could also do positive indexing and negative indexing. And yeah, so those are the few things that you would like to keep in mind. Coming back to the problem that we were trying to resolve. So we have two tuples now, 6 and 4, and we are slicing the first 4 elements from tuple 6. So we are getting 1 1 1 3, and we are concatenating this sliced portion with tuple 4. So this is my tuple 4. I'm concatenating it with tuple 4, and then what am I getting? There you have it. So I had 113 113 from my slice tuple. There you have it. And this is concatenated with the 4 strings here. So there you have it. Now, can we omit the parentheses in tuples? Again, this is not something that you would be doing, but it's still good to know about it. In case you encounter some random code, you find that there are no parentheses. Do not get confused, it's a tuple. So if I'm creating this tuple, and if I'm displaying the type, there you have it. It's a tuple. So parentheses, it appears that parentheses for tuples is optional. But again, do not do this. It's not recommended because it makes your code unnecessarily complicated. Now again, can we nest items in tuples? I think I mentioned this right at the outset when we were trying to create a string of tuple, a tuple of strings. When we were trying to create a tuple of strings, I had mentioned this, that we can have nesting in tuples, but this is how we do it. This is how we nest elements in a tuple. So you pass a list of items, and now if I print this out, tuple underscore 12 gets created, and let's say I want to find this particular element. Let's say I want to find 300. Then what do I do? See, my tuple has two levels now. What is the first level? The first level is, of course, here we have 0, 1, 2, 3. Now, when we are accessing the fourth item, when we are accessing the item at index 4, let's put it that way. When we are accessing the item at index 4, this is the item. Now, this is once again another sequential data structure. In this case, it's a list. So, this can be indexed once again. So what do I want? I want 300. So 300 is present at which index of my list? 100 is present at index 0, 200 is at index 1, and 300 is at index 2. So now if I pass 2 here, there you go, I get 300. And what happens if I pass 1? If I do 4, 1, then what happens? Okay, typo there. No, I don't want 4 2. I want to see what happens when it's 4 1. I get 200. And if it's 4 0, it's 100. So this is how we nest items in tuples. Again, a question that often arises is, why do we need tuples when we already have lists which supports a larger set of operations? To be very honest with you, tuples are not as commonly used as lists. However, tuples have one very important property that is often taken advantage of, and that important property is immutability. And that is the whole point of all this discussion. Tuples are immutable, and believe it or not, that immutability property adds a lot of power to tuples. For example, if you decide to pass an object or a collection of objects around your program as a list, then what would happen? It can be changed anywhere because these are all list items. However, if you pass these objects as a tuple, they cannot be changed. Once tuples are created, they cannot be changed. And if you want to enforce this constraint, tuples are the data structures that you would be looking at. So once you enclose your objects within a tuple, they cannot be changed. And if they cannot be changed, it means that the integrity of these objects is intact. It's guaranteed to be preserved. So that is how tuples are an advantage over lists in this special scenario. I hope this video was meaningful for all of you. I would request you to like this video, subscribe to my channel, and share this video as much as you can so that I get the motivation that is often required in order to record more such videos. If you found that there was some mistake from my end, or you probably did not understand something all that well, you feel free to leave your comments in the section below. I'll positively answer to each and every comment that I see, and I'll try to resolve your doubts. And this will also help me to understand where I'm lacking and thereby help me to become a better instructor, to become a better teacher. This is the one activity that I enjoy doing, regardless of the time of the day. It's never tiring, and it's always a refreshing feeling to teach, whether it be in physical mode or whether it be recording classes like this. Something that I thoroughly enjoy, and it helps me to get my sanity back. It helps to keep a sanity check on me. Okay, with all the commotion that goes around day in and day out, it's very hard to keep your balance. But if you have this one activity that you really enjoy doing, that can really work as a stress buster. And for me, it's teaching. So recording videos like this is always a great motivation. So thank you for sticking around till the end. I'll not be prolonging the video anymore. I'll see you in the next one. Bye bye.